Cool. Looks like we're going. So back looking at Geth again. So I got up to the blockchain, really, and that might be the most important part of the whole package. I don't think it's going to be super complicated, but it is big, so who knows what's going to be in there. I have played it for a little bit when everything references it, because everything references it, essentially. But what happens really is your Geth, when you start it up, spins up a node. And we can think of node as just a structure that encompasses everything that the program does. So it spins up a node, and in this package it has the ability to interact with several services, one of which being this ETH service. And the ETH service provides the ability to talk over the protocol, and then it will save it to the structure that is a blockchain structure. So yeah, ETH uses a peer-to-peer network, talks to it, then saves it into core and into blockchain. And here we go, blockchain. God damn it. Go. And as we can see, 1600 lines. Super fun. We start at the top. It's loading absolutely everything. Got some random errors. The genesis is not found in the chain. That'd be a shitty error to have. Someone would have deleted it out from you. Cache limits. Cool. So they play a lot with the database, the underlying database, to make it quicker. And they play a lot with the tree structures before saving them to the database, and really everything that happens in there, they try not to write so much to it because it's just huge, so they make these caches. But that's just a config. Don't care about that. Blockchain represents the canonical chain given a database. So pretty much you pass it a database. You start up, you call load ETH database has an interface, the database interface, and you load level database somewhere, and then that gets passed to the new blockchain here and saved here. And if the database has got stuff in it, one of the keys that you can search for in a database is the header, and that will pass the top hash that you can search, and then you can use that to build the blockchain from the database. So got a blockchain structure. It's got some config files. The chain config, my understanding is most of that's pulled from the Genesis file. Like it should all be saved in Genesis. Not sure about that too much. I haven't dug enough into it, but every time I sort of look at it, they sort of build this chain config from the Genesis file. But not always. It's also tmux, cd chain, core, vm chain, blockchain even, Codebase.go. And if we go back home, Geth dump config. Now, I don't think there's any chain stuff in here. But if there was, I'd like to know before I get too far into it. Not by the looks of it. So we scroll down. It's got this header chain. And that's a temporary structure where they just chuck headers that they're working on. Most of this stuff is temporary. So, like the number of the current block and the fast block. State cache is the actual cache. Because everything in the end gets saved to this database. So when you want to do stuff, you're working with the database. So the state is actually querying that database in the end. But instead of having to query the database, they keep a cache of things to make it a lot quicker. The consensus engine being the proof of work, the processor, validator is what a block gets handed to. So the blockchain will have a command somewhere that says process block, and then it'll hand it straight off to the processor, and that'll make sure that the block is valid, and that'll be according to what the consensus engine does. I imagine it utilizes the consensus action actually. So we've got the new blockchain, and this is just taking a database, cache config, chain config, engine. I wonder if we can find somewhere quickly that actually says the new blockchain. And if I think I can remember back, it might be in Node. New blockchain? What's it called? City node. Nope. Helper test. New blockchain. eth.backends.go. So up in ETH, in backend. Cool. So we spin up new, which is the Ethereum service object. And I think this is actually the eth.new. Yeah, okay, cool. So when you spin up a node, it tells you want the ETH service, which is where we're looking at the file we're looking at right now. And in new, which it calls, blah, 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 sets some settings in the config files, then actually calls new blockchain somewhere. Way down here. So they made the Ethereum structure. and then they make the blockchain, they set it. ETH.engine VM config should preserve. ChainDB, where's that come from? Create database. Cool, that's all fun. So they made the blockchain, gets called new blockchain. These are setting up blanknesses. I haven't looked into LRU yet. I'm not fully sure what it is. Let's have a look. Line replaceable unit? Nah, aviation. Nah, unimportant. New block validator, new processor. I wonder if those are in this file. Not in this one. Gym block validator. There's a file for it. Imagine state processor does too. Yep, cool. So we've got files nearby, state processor and block validator. Probably will go for them eventually, but they're just going to look at a block, make sure it's legit. So we've got wrong file. And the first thing it does so it builds the header chain. So it goes through the database, I imagine, and digs up every single header. So they can have it in a file, easy to get to. Blockchain get header by hash if it does not equal nil. So they go through bad hashes. Which is not anywhere there. So they got this file here which manually tracks bad hashes. And they're going to be the DAO hacks. And if anything goes to the bad one, straight out abort. Abort. So, yep, first thing they do, build the header chain. And then nope, where am I? I'm in the wrong place. New header chain. Get block by number Genesis block. So the Genesis block, as I sort of mentioned earlier, is where they save all the chain configs. So it's got some important information there. Get block by number 0, first one, not too complicated. Load last state. That might be an important function to look at. It sounds like they're loading the state, and I'd like to know how to do that. Then they go through the bad hashes. Found bad hash, rewind it. Not straight up abort. Cool. So this load last state probably is semi-important, and it looks like it's getting called right here. Load the last known chain state from the database. This assumes that the chain manager mutex is held. So raw database, read block hash. Database. Read block hash. So the database has a head, which is just everything in the database is saved as a hash, like it's a key file, a key value file, similar to just a map in Go or any real hash in any programming language. There's a key and there's a value. And all the keys in the blockchain are hashes, except for the head, which is an underscore or something random. What are we looking for? Read head block hash. And here it is here. Head block key. So it's called database.get head block key. I wonder if that's in here. Nope, it never is. Ac head block key. Last block. It might just be saved as last block. Schema. So I guess here are some interesting things that define low-level database schema. But what it's saying is, if you search in your blockchain, the last block, it'll give you a hash, I imagine. Yeah, bytes to hash. So turn the bytes that are given here into a hash. And that is the most recent block in your database. So you get the most recent block, which is a hash. So you should be able to look, get block by hash. It gives you the current block. And then what are they going to do with that? State.new current block get root. So you got the current block. They've called blockchain get the block. And each block has the root, which is the state root. And then they build this new state structure with it. And they pass it a state cache to work with. And that really, I guess, that builds the state. So that's kind of interesting, and that'll be what I look at next. State.new. If it doesn't, then it's broken and needs to be fixed here. Everything seems to be fine. Set as the head block. Current header equals current block dot header. So they get the header out of it. Read header hash. So the raw database, read header hash, and they pass it to blockchain database. Head does not equal blank. Set current header. So I'm not sure, they're doing a little bit roundabout here. I don't know what raw database does really. Like what's, might be just a way of working with the database structure without actually doing any complex stuff behind it, maybe, I don't know. But they're getting the last known header, which I thought current block.header would give them. Oh no, wait. This is reading the header hash. So when we looked at here, there's a header hash. Yeah, so it just database.gets header key, which is up here as last header. So they've got the header, they've gone and got the latest block by searching the database for last block. They've extracted the header out of that here in current header. And then they're also going back and they're looking at the database and they're saying read header hash, which is calling database.read header key being last header, and then if that doesn't equal blank hash, header equals get header by hash. So they search for the header by hash, that does not equal nil, and they set it to that. Which I find interesting because if there's something in there, it is overriding what they found in the current block header. I thought it'd be nice for them to check that those two are the same. Anyway, so they set the current header, which is pulled out of this part here. They get the fast head block. So Ethereum's differentiating between regular and fast blocks, which haven't been checked. Don't want to dig into that too much. Status log for the user, current fast block. So they're doing some logging here, but they're getting a total difficulty, blocked total difficulty, and a fast total difficulty, all from the header block and fast block. And then they're logging it. Loaded most recent header. Loaded most recent local header. Geth. Control C. Loaded most recent local full block number 0. So I'm at 0. Fast block number 236. Cool. So that's where it gets that from. So this really just builds load last state. It's chain state. It's not even a tree state tree yet. They're calling this state.new, and that obviously is building everything. So that's pretty easy so far. Load last state gets the header and gets the last block and saves it into the blockchain, like current block here. Cool. So that's all good. Once you get a blockchain, it's initialized. You're not doing anything with it. So it just kind of sits there after that point. I mean, it's loading the state, which I haven't dug into, but it's calling state.new. Set head rewinds the local chain to a new head. In the case of headers, everything above the new head will be deleted. Yee. Cool. So was that called at all below? If something went wrong, did it say set head? Yeah, if they get a bad hash, they call it. That's just going to be deleting stuff if your chain is screwed up. So skipping that. Fast sync commit head. That also seems pretty ordinary. Gas limit returns the gas limit of the current head block. So each block has a gas limit, and when you change the gas limit in the next one, it should be plus or minus 1% of that, 0.1% of that, or something like. It's actually divided by 1024. Current block retrieves the current block head from the canonical chain. Current fast block, so these are all really not, they're just getters and setters at this point. Set the processor, set the validator, get the validator, or returns the current validator, returns the processor. State returns a new mutable state based on the current head block. Yeah, that could be interesting. So they call state at current block.root. And they just call state.new. That looks like what I want to dig into next, obviously. Reset purges the entire blockchain, restoring it to its genesis state. It calls this reset with genesis block. So this is all housekeeping, really. You know, what happens if something goes wrong? You have to delete and change and update, and it's a pretty complicated structure, I imagine. So reset and set head to 0. Cool. Prepare the genesis block. Right, total difficulty. Right, block. Genesis. So delete everything, really. get the Genesis block. And Genesis is actually a package, so they got it dedicated. They set the Genesis block, they insert it, they write the block, delete everything, put the Genesis block in there, nothing else. Repair, more housekeeping. Stuff goes wrong, you got to fix it. And I imagine this is where a lot of effort has gone, because when stuff goes wrong with blockchain, I imagine it goes wrong pretty quick. And you're trying to keep lots of shit together that doesn't want to stay together. Repair tries to repair the current blockchain by rolling back the current block. So they call it state.new. So they've got the state which is saved temporarily to memory. If your computer crashes, there's a lot of stuff that was going on in memory that didn't get saved. They have to roll back to what actually was in the saved state. So it just rolls it back. Which you'd hope it'd only be one, like, because you'd think it'd save after everyone, but maybe not. Export writes the active chain to the given writer. Calls export n, which is right below it. Writes a subset of the active chain to the given writer. So this is, you can save your blockchain as it is to a JSON file, I believe. And N is just, you can save between the first and last block. Whereas export would save all of them, starting at 0, going to current block. If first is greater than last, then you've done something wrong. Where's that end? So that goes to there. Exporting batches of blocks. Last minus first plus 1. Reporting on the time that they start. Get block by number. They've got the number. Encode the block to RLP. Into W, which is their writer, I guess, somewhere. Oh, and you pass the writer in here. So they're getting the block, and they're writing the block into your writer, which is just going to be your file. Anything with a .write function is a writer. If time since greater than stats report limit, cool. So that's just to stop it from writing, because it writes, you've exported X amount of blocks, first to last, and they make it pretty duration, which is just them saying it should be in hours ago instead of a 24-hour time that's ugly. Insert injects a new head block into the current blockchain. So you pass it one block. This assumes that the block is indeed a true head. It will also reset the header, and the fasting block to the very same block if they are older. So you pass it a block. Update heads, read canonical hash. If the block is on the side chain or an unknown one, force the other heads onto it. Raw database, write canonical hash. So there's a lot of stuff going on in this raw database now, which is writing it. I imagine it's writing it directly to it. So let's pull it up actually. What's it called? Write canonical hash. Write canonical hash. What's that do? Database put header hash key and hash.bytes. Header hash key number. Header prefix plus number plus header hash suffix. So what's header? So you put a H here, dash number, and then the hash for header, I guess. Cool. So that's how it's stored in there. db.put. Right, head block hash. Head block key. So that's what we were looking at before, where it's, what's it called? Last block. Into last block is the key. They save the bytes of the hash. Current block dot store. So current block is a atomic, I thought it was. Atomic.value, current head. But that's just so you can access it. Store the block in the current block. If the block is better than our head or is on a different chain, yeah, force it to update. Set current header, header chain, raw database, write head fastblock hash, current fastblock store. So there's writing the block to everything. So the blockchain, the blockchain has 1,000 header and block structures on it, and it's just going through them one by one and saving them. genesis literally calls the genesis of it. So it's a getter. Get body. So get past a hash. Caching it if it's found. So they search body cache. If it's there, they return it. Maybe. Else raw database read body. So read body RLP. So they build the read body RLP. What was that one? Database.get block body key. Say block body key. Append block body prefix. And it's a B. So they append prepend B and the block number to the actual hash before they save it into the database. Cool. That gets it and they return it straight away. And do nothing with it. So it's just raw data at this point. And then down here, read body calls RLP decode on it, which puts it into types.body, which was a random structure, I believe. If you go to blocks. No, it wasn't in blocks, it was in types. Types blocks. Body is a simple data container. Cool. With just transactions and uncles. So it's literally exactly what it is. They've saved it to a database. It's the hash that's saved into the database, plus they've done some prefixing so you know what's going on if you just look at the database. It's saved as RLP. They drag it out. They call decode on it, and they pass it to this body structure, and they return that body structure. And they add it to the cache. Get body RLP does the same thing, I guess, but it doesn't call. Oh, so it does the. It returns the RLP coding. Yeah, it's got an RLP raw. Has block. Calls has body. Database.has block body key. So they're searching for them in the database. Has state. Checks if the state tree is fully present in the database. And looks at state cache. Cool. More state stuff. Has block and state. So you pass it the hash to check that the block is actually in there. State cache open tree hash. So it looks to make sure that the tree structure is right. I guess. Haven't dug enough into state yet to fully understand it. Has block and state, does the same two things, get block. It's just going to call this raw database read block. Adds it to the cache. They add everything to the cache so they don't have to search it if they do. Database hitting is slow, so get block by hash, that's another getter. Get block by number. Read canonical hash. Get block. Cool. Get receipts by hash. So there's a receipts tree, and you pass it a hash for that receipt. So raw database, read receipts. Block receipts key. And it's got an R in front of it. So this is all saved in the receipts are saved into the same database. It's all in one. And there's more getters, and they're just passing it straight to this raw database structure, which is just formatting it to look into the get blocks by hash, returns n amount of them. Get uncles in chain. Get block parents. Trie node retrieves a block of data associated with the tree node, either from the cache or persistent. More state stuff, which I want to look into more. Stops the blockchain service, so they kill it. They kill all the channels that they've got set up as well, and deleting all the caches and stuff. Process future blocks. So instead of putting them all into the block to process, they queue them up in a future blocks channel, I imagine. And if they do that, they end up calling insert chain on blocks. Cool. Rollback is designed to remove a chain of links from the database that aren't certain enough to be valid. Chain of links. Set receipts data. Computes all the receipts fields. Cool. This is now deviating from blockchain stuff. Set receipts chain. Cool. So I might call it there for today. And then tomorrow go through the state.new, because that kind of seems important. Write blocks of state, because they're all starting to do stuff with state now. And until we fully get head around state, it's just going to be painful. So he's doing stuff with receipts. I'm not sure. Insert chain. Attempts to insert a given batch of blocks. Calls insert chain, which is insert chain below. And we had a look at this the other day when the downloader was calling this exact function to put in the blocks. So that's chain is just an array of blocks. make sure the chain is actually ordered and linked. For blocking block, headers, verify headers, start cache for blocking chain. If it's in bad hashes, ignore it. Validate the body. Create a new state with it. Process the block and get the, so that's going to actually call the proof of work stuff on it. Validate the state on it. Blockchain write blocks with state to the chain. So that's where it's actually written to the chain. Report statistics. So it says login and reporting. Count transactions in the block. Total transactions in the whole chain. Reorgs takes an old chain, new chain. Cool. So this last stuff is mostly skipping over. Post chain events. Update. Bad blocks. Yeah. Log error. Insert header chain. Okay, so this looks a bit more important. Validate header chain. So when you download headers, it calls this. And it's just calling insert header chain. So there's a header chain structure. It's here. This is a decent file. But it's just going to be an array of headers, really. Right header just puts one onto that header chain. Current header has more getters and setters. Cool, and that's it. So a lot of that stuff had to do with state. So I want to go through the state and then probably come back to this again. Anyway, thanks for tuning in.